All right, hello. This is going to be a video lesson doing sort of a wrap up of Chapter 3. We're mostly going to look at Section 3.5, but right now I'm on the last page of 3.4. So we're on page 104. And basically, before we move on to a totally new topic in Chapter 4, we wanted to have a quick review day. But I think this video is going to be a little bit shorter. Usually, these problems at the end of a chapter, I will just kind of leave for you to do on your own. We might do some of it in class, depending on how much time we have. But yeah, I think today I'll do some of them, but I'll save some of the problems just for you to do on your own. All right, before we get to the actual problems, let's look at page 104. So I really like that towards the end of each chapter, there is kind of a summary page like this. So it's a list of key topics. It says if I were studying, I would make sure I knew all of these. And, I think in Chapter 2, we had a lot of formulas. And in Chapter 3, we don't. We don't have a lot of formulas, but we do have a lot of definitions. So you know what kind of student you are. You know if you're the type of student who likes to study with flashcards or notes or outlines, whatever studying method you use. I feel like maybe I would do flashcards for something like this when there's so many definitions, but it's up to you how you want to study. So I'm not going to repeat all the definitions right now, but yeah, we know what a set is, elements of a set. The empty set can be written with this symbol, or it can be written with that symbol. And, we want to know the correct notation, the correct symbols. So, right, sets should have brackets, elements should have commas in between them. On an exam, when we get to an exam, you're going to want to have the correct notation. Cardinality is also known as the cardinal number. Of a set, and that could be written as this or this. They mean the same thing. It's the number of elements in a set. Finite and infinite sets. So an example of an infinite set would be this one, the set of all natural numbers. So you can go back to when we talked about that. That was either in 3.1 or 3.2, I think. But yeah, that's a set that has infinitely many things in it. Let's see. Roster notation, set builder notation, subset versus proper subset. So a subset, we use this. Proper subset, we use this. Oh, here's that notation again for the empty set. I wrote it up above. The number of subsets. I think we'll do one of those examples in a few minutes, but the number of subsets of something. There was kind of a little formula for that. I'll talk about when we do the example. Listing all the subsets. Yeah, C and D will both be in this example I'll do. And then we talked about Venn diagrams. So this is some of the more recent stuff. Universal set is usually with an uppercase U. The complement of a set looks like that. The intersection of sets could be something like this. Union. So you should know what those symbols mean. Cardinality of the union and intersection of sets. And then creation of Venn diagrams, typically with 2 sets or 3 sets, might be like an A, B, C. And then survey problems was the last thing we did. And the survey problems seemed like most of them had 3 sets, like an A, B, and C, all within some kind of universal set. And, those can be kind of tricky. I think there's one of those in this upcoming 3.5. All right, so here's what I'm going to do. I'm going to look at some of the problems in 3.5, but I'm not going to do all of them. I want you to just work on some on your own. But I will tell you that I have solutions posted. By the time you're watching this, I do have solutions posted. But I want to go over a few of them in this video so that I can talk about them. And, that's on the same page that has our workbook where I sometimes post PDFs. All right, let's see. It does warn you, use proper notation and terminology. Yeah, for full credit, we want to see brackets where you need brackets, commas where you should have commas, all of that stuff. Show work where it's needed. It might not be required for everything. Just depends on the kind of problem it is. All right. Let's see. Determine whether these statements are true or false. And it does say explain your reasoning. Okay, so they're telling us make sure you explain. So why don't I start this one? I don't think I'll do all of it, but I do think this chapter is very good for true or false questions. That's a good way for us to test you on if you understand all the definitions. This is the empty set, and sometimes the empty set gets used in like little tricky true or false questions. Let's remember this means proper subset. So you can look back at section 3.2 when we talked about what it means to be a subset, what it means to be a proper subset. I'm going to say this one is false. And I'll give you an example of how I would explain why I know this is false. Let's write some sentences, maybe one or two sentences. This and this are two ways of writing the empty set. And we said in 3.2 that the empty set is not a proper subset of itself. I remember that note being on a page. It might have actually been in bold. I don't have it in front of me to check, but it was a little note that, yeah, it was probably right when we talked about the empty set and proper subsets. A little note there that said it's the empty set is a subset of every set, but it is not a proper subset of itself. I think that's how that note was phrased. All right, let me save B and C for you to try on your own. This one wants to make sure you know what the word equivalent means, what the word equal means. All right, so let me save those. Let's take a look at the next page. Yeah, let's do this one. Number 2, looks like a word problem. Members are offered options when joining a new gym. They can choose none, some, or all of the options. Wait, that might be important. None, some, or all of the options. The options available are P, S, Y, and B. How many options are there? Okay, so it looks like there are 4 different things, but it also told us that a member of the gym could choose to do none of them, or some of them, or all of them. So how many options are there? List all the possible options. So here's what I'm thinking. If I'm a member of this gym, I could choose to do all 4 of these things, or I could choose to do any 3 of them, or I could choose to do any 2 of them, or any 1 of them, or I could choose to do none of them. So there's actually a lot of choices, right? If these are the 4 things available to us, I feel like the options to me as a member are any subset of P, S, Y, and B. Yeah, this is kind of something you could think of as subsets. Because I could choose everything, all four of them, or I could just choose some of them, or even I could choose none of them. That's still technically a subset. The question was how many are there? What's the number of them? There was a little formula in that section, and it is 2 raised to a power. In this case, it's 2 raised to the 4. 2 raised to the 4, remember, it's 2 times 2 times 2 times 2. You could do it by hand, or you could do it with a calculator, but you should get 16 of these. All right, so you could see section 3.2. In section 3.2, I think the formula said 2 to the n, and in this case, it was 2 to the 4. All right, so there were 4 things here, so I did 2 to the 4. Part B wants me to list the options that are available. It says up here, list all the possible options. Well, I'm going to do that here. And I should have 16 things that I'm about to say. So it doesn't really matter what order I list them in, as long as I have all 16. Now, how do we want to phrase this? I don't want to write out all of these words 16 times. So let's use the abbreviations, P, S, Y, and B. And there's a little bit of flexibility in how you label this. I'm going to just start writing. First of all, I could do none. That's a choice. I could do choice P, choice S, choice Y, choice B. Those are all the possible ones where I choose just to do one thing. I join the gym and I just want to do private training, or whatever. Or I could choose to do 2 things. So how do we want to list? If I do, let's say, P and S, do we want to write P and S? I guess you could do a plus sign or something if you want. I'm just going to write PS. Let's say that's a choice. Let's say PY. That's another choice. PB. That's a choice. I think if you wanted, you could write the word and, or you could put a little plus sign or something like that. But I think the way I'm doing it here is also good. Those look like the sort of options that have 2 kinds of classes. And what about S? S with Y? S with B? I think we got everything that has P, everything that has S. Oh, we need the possibility that you do Y and B. I think we got all of the possible ways of doing just 2 classes. So now we could do 3 classes. We could do P, S, and Y. We could do P, S, and B. Remember, I'm expecting to have a total of 16 things on my list. I could do P, Y, and B. I could do S, Y, and B. That looks like all the ways you could do 3 things. And then, well, you could count up how many things we have. We're missing one possible option, and that is P, S, Y, B. That's where you do all 4 of them. So how many do we have? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're good. All right. Let's see. Let's take a look at the next page. Number 3, I'll do some of this. I think number 3, I think this type of problem is pretty important. This is from that section that had set operations. It was, I think it was 3.3, where we talked about union and intersection and complement. So you have to know what those symbols mean. And all right, we have U, A, B, and C. I think U looks like it's the universal set. A, B, and C are all subsets of U. They're all smaller subsets of U. All right, first one wants me to find A complement. So remember, this is all elements that are in U but not in A. So I don't even need to look at B and C for this one. Let's say A complement equals, we should have brackets for this because it's a set, and you could actually just look at U and kind of go one at a time and decide, do I need to put it in my answer or not? Or you could, it's up to you. Do you want to like look at U first or do you want to look at A first? But the number 0 is in A, so I'm not going to write it. The number 1 is in A, so I'm not going to write it. The number 2 is missing. 2 is in U, but it's not in A. So it goes here. 3 is in A. 4 is in U, but it is not in A. And keep going like that. Skip 5, write 6. Skip 7, write 8. Everything that we're almost done. 9 is in U, but it's not in A, so write it. 10 is in U, but it's not in A. All right, so that's a good answer. And we wrote it with brackets and commas. Looks really good. Let's look at part B. This one has parentheses. So remember, in math, when you see parentheses, you should do what's in the parentheses first. And that means that the little complement up there, we're going to save that for last. In fact, if you want, you could just find this by itself as like a step. Maybe I'll do this on its own line, and then I'll find the final thing after it. So this is the union, right? Union means we want to take any element that is in A or C, or both. So looking at my set A, my set C, I can't fit all of it. Oh yeah, I could maybe fit this on the screen. A and C are here, and let's just go from sort of smallest to largest. So the number 0 is in A. The number 1 is in A. 2 is not in either of them, so skip it. 3 is in both of them. Both is allowed. 4 is in C. So I'm taking any number that is in A or C or both. 5, 6, 7, 8. But let's be careful. That's not my final answer. That was the part that was in parentheses. So all right. So listen, if you haven't tried any of these on your own yet, this is a good place where you could pause the video and try to finish this and then check back with me. If we were in class, I would ask you to do a lot of this on your own. I'm just trying to show you so you have something to compare to. All right, kind of like what we did in part A. Go through this set, and you want the complement of it. So anything that is in U, but not in this set. So this set does not include a 2, it does not include a 9, and it does not include 10. So this is my final answer. So I think I'll save part C for you to try on your own. And again, I have the solutions posted. You won't hear me talk through it, but you could still check the solution on Blackboard. All right, let's look at the next page. Okay, I think the next 2 pages are survey problems, and that's the stuff we did recently. So maybe what I'll do is I'll do number 4, and then I'll save number 5 for you to just work on your own. All right, number 4. Survey had 208 college students determine if they take math and science courses. Some students are taking both. So I'm thinking right away, those are my categories: math course, science course. There's an overlap, there's an intersection where some students take both. 112 were taking math, and 108 were taking science. Construct a Venn diagram and answer the following questions. So I think in a problem like this, if it was a quiz or an exam, some of the credit would be for constructing the diagram, and then some of the credit would be the questions down below. Let's label these math and science. Let's just do M and S. And remember, in that section on surveys, it was suggested that you try to work from the middle. You try to work from the innermost region and then work your way out. Usually you can do that. I think that maybe the last problem from 3.4 was a little tricky because we had to do it in a different order. But usually you can try to work from the center and work your way out. This does tell us 45 were taking both, so there are 45 students in that overlapping area, the overlapping shape. Now, 112 students were taking math, but don't write 112 here, right? You don't want to write 112 because you already have 45 students in the circle of math, right? The circle of M already has 45 students. So if you put 112 here, that's going to be too many. You can do a little scratch work and say, how many do we need to write? Well, 112 minus 45. You could use a calculator. That's 67. So 67 are here, 45 are here, and now we do have a total of 112 students in the circle of math. Do something similar for science. It says 108, but we don't want to write 108. We want to say there's already 45 of them, so 108 minus 45. My little scratch work off to the side. You could use a calculator for that, or do it by hand, and you get 63. 63 goes in here. And now, if I add that up, I see I have the correct number. I have 108 students in the circle of S. Do we need to do anything else? There is a number that we haven't used yet. It's the 208. So there were 208 students overall, and then I think, yeah, we need some kind of number out here. It's not going to be 208 because we already have a lot of students here, right? So I think what we want to do is do 208 minus all other categories. Let me see if I have my calculator handy. Yeah, I do. So when I say all other categories, 208 minus the 67 minus 45 minus 63, I get 33, and that's what I'll put somewhere out here in this box. I usually put it in the lower right. And I'll move my calculator away, and let's just take a quick look. Does this make sense? I think it's always a good idea to do like a quick reality check. You could double check, 45 are taking both. You know what else you could do? Add up all of the numbers. Let me clear my calculator. Every number that I wrote in the Venn diagram, if I add up all of those numbers, it should add up to the total number of people who were doing a survey. So that's a good thing to check. If you ever check and you get the wrong thing, then it means something went wrong and you should go back and double check things. All right, but we're done with the Venn diagram part. And, that can be tricky if it's a problem that has 3 circles, so just take your time with it. But we did a bunch of those in 3-4. All right, how many students were taking neither? Oh, well, that's the last thing we answered, isn't it? Because any student who's sort of floating around out here, they're not in the circle of math, they're not in the circle of science, This is 33. So it's like we already did the work. So now we just have to figure out what it's asking for. How many students were taking a math class or a science class, but not both? But not both. Well, 45 were taking both, right? The 67, they're taking only math, and the 63, they're taking only science, and we don't want the 45. So just go 67 plus 63. It's all of those students. They're taking only math or only science. This adds up to 130. All right. So I'm going to save problem 5 for you to try on your own. It is this same kind of problem, and you can also compare it with the ones we did in 3.4. So I guess let's skip ahead then to page 110. All right, more true and false. I told you true and false. I think true and false are important to me for this chapter. All right, so I would encourage you to try these on your own. Don't just let me do it for you. You know, maybe pause the video and try these on your own if you haven't already. So, mark each statement as true or false, and it just has little circles for us, so it doesn't really say that we have to give an explanation. So I would say for problem 6, we don't have to give an explanation. The first thing I notice here is this set A is written with dots in it. So 1, 3, 5, 7, 9. This is odd numbers. Usually you put dots to indicate that there's like more numbers in here. And yeah, there's all the odd numbers from 1 to 15. I just noticed that there's only one number in here. There's only the number 11 in there. So I think usually in math, we probably wouldn't put the dots usually if it's only replacing one number. Usually dots are used for like a longer spread of numbers, but that's fine. There's nothing wrong with it. But yeah, that's the number 11 is living in those dots. Okay, let me see. We need to do things like A intersected with C, A intersected with B. There's A intersected with B again. So I decided off to the side before answering these, I decided to just do a quick what is A intersected with B, because I see we need it for a couple of these. So I did that as a little side problem, taking everything that's in A and B. So like the number 1 is in A and B. The number 3 is in A and B. The number 5 is in A and B. So I'll just have that off to the side if I need it. While I'm at it, I'm going to go ahead and find this. A intersected with B intersected with C. A intersect B intersect C. So that would actually be numbers that are in all 3 of them. So like the number 1 is only in A and B. The number 3 is in all 3 of them. The number 5 is in all 3 of them. So I have that off to the side. Even if a problem doesn't need explanations written, you might find yourself wanting to write a tiny bit of scratch work just to help yourself out. All right, let's see. Does C equal A intersected with C? It does, yes. True. True, because you could do a little scratch work to write A intersected with C. But yeah, the idea is that A intersected with C would have 3, because it's in both of them, 5, because it's in both of them, 9 is in both of them, and 11 is in both of them. So yes, they have all of the exact same elements. Part B, is B a subset of this? Well, that's why it helps that I wrote this off to the side. A intersected with B has 1, 3, and 5. The set B has some stuff that is not in this set, like the number 2 and the number 4. And for that reason, this is false. So let me say that again. The reason why this is false is because some of the things in B are not in this set, 2 and 4. They're in B, and they're not in this set. That's what makes this false. Next up, A intersected with B. I have that here, 1, 3, 5. So this is basically saying, does the set 1, 3, 5 equal the set 3, 5? No. No, because we found them. 1, 3, 5 is not the same as just 3, 5. Okay? And finally, is the empty set a subset of B? That is true. And that's because back when subsets were first talked about, the empty set is a subset of all sets. It's a little technicality. It's like an empty container, and we say, yeah, it's a subset of anything. All right, so I'm trying to help out with some of this, but I don't know if I'm going to do all of it. Let's see. All right, let's look at number 7. I want to remind you that this is another notation showing up, but this is the same thing as this notation. It means complement. Okay? I usually write it with C, but we did say it both ways. I think it was section 3.3 that we saw that. Okay, define these sets A, B, C. Oh, B is defined in kind of an interesting way. So remember, that's all natural numbers. The fancy looking N. So a natural number includes 1, 2, 3, etc. Goes up and up and up forever. So B looks like it's the set of all numbers such that this number is a natural number and it's between 4 and 10. Well, it's, I guess, x is greater than or equal to 4 and x is less than 10. Tell you what, since I'm focused so much on B, let's just go straight to this one. I'll save part A for you to do. You can kind of fill that in and you can check that with the posted solution. But I'm kind of looking a lot at this set B. I want all natural numbers so that this inequality is true. And I'm going to go ahead and I'll find the set B first as like a stepping stone. Once I know what B is, then I can figure out what B complement is, and then I can answer the question. So I think I'll do that. I think let's start at 4 and work our way up, right? 4, 5, 6. Numbers that are between 4 and 10. And I want this to be true. I want the number to be greater than or equal to 4. So 4, 5, 6. And I want only the numbers that are less than 10. So let's go 7, 8, 9, stop. That is what the set B is. I know the set B was kind of given in a complicated way, but that's really what the set B is. Now that I know what B is, I could find B complement, or the complement of B, and that would be everything in the universal set U that is not in the set B. Usually, a universal set is pretty big. What's our universal set here? It goes from 3 to 22. Okay, there's a lot in there. There's a lot living in those dots between 5 and 22. So let's just start writing numbers that are in U but not in B. So I guess 3 and then well, 4, 5, 6, 7, 8, 9, those are all in B. So then we start again at 10. 10, 11, 12. These are all things that are in U, but they're not in B. And at some point, I'll switch to writing dots because I can tell that we're going to be writing these for a while if we write them all out. But this does stop somewhere, right? I mean, U goes up to 22. So let's say this goes up to 22. You see how I'm kind of making a problem within the problem? Like, this didn't tell me that I had to find B, but I kind of knew that I needed B in order to find B complement, and I need B complement so that I can do this. Now I can finally do what it's asking for. So that's the union symbol, the one that looks like a U. So I want every element that is in U, or I'm sorry, it's in C or it's in B complement. So let's see, C is here, 11, 13, 17. There's only 5 things in C. Any number that is in C or B complement or both. I usually list them starting with like the smallest numbers first. I'll do 3 because it's here. I'll do 10. 11 is in both. 12 is in this one. 13 is in both. Well, actually, think about it. Anything that's in these dots is still going to be there, right? So I could just do dot, dot, dot again and go all the way up to 22. So I think what happened here is most of the things in the answer came from B complement. Really, everything in the answer came from B complement. I don't think that C had anything that B complement didn't have already. All right, but that could happen. Let's take a look at one more, and we'll look at part C, and then maybe I'll save the rest for you. I think we did something like this earlier. I think in order to do this, you should think about what's in the parentheses first. So I'm going to go ahead and do this as like a little problem within the problem. I'll find A intersected with B. So my A is written above, my B is written above, and I'll write brackets. So remember, for that symbol, intersection, you want numbers that are in A and B. So the number 5, that's in both of them. The number 7, that's in both of them. And the number 9, that's in both of them. And now I could answer the complement of it. I think this is going to be a pretty big set. I think there are a lot of things in this. When you have to do a complement, it's kind of like doing the opposite. So, the opposite of this set. So, because this set was pretty small, it only has 3 things, the complement is going to be pretty big. We want everything that is in U, and you have to look at U for this problem. You know, each problem has its own U. Everything that's in U, but not in here. So not 5, not 7, and not 9. I skipped 5, skipping 7, skipping 9. All right, I've skipped everything I needed to skip, and now we just keep counting. 11, 12, 13. I'm glancing up at the set U, and I'm thinking, I need to go all the way to 22. So, should I list them all, or should I switch to dots? It's up to you. You could list them all to be extra careful. I think I'll switch to dots. Maybe at the end I'll list 21, 22. You want to list enough to make it clear what the pattern is, or what's in here. I think because I wrote 10, 11, 12, 13, 14, 15, you can tell that this keeps going 16, 17, 18, 19, 20. So, yeah, I think the way that I wrote it here is good. All right, so I think we'll wrap this up here. I want to save the rest of the problems for you, and you can, try them on your own and compare to what I posted on Blackboard. But yeah, feel free to let me know if you have any questions. You want to make sure you know the definitions, the symbols, and just that sets make sense to you. It can be a little tricky with subsets and unions and intersections and all that. So yeah, feel free to ask me if you have questions. And other than that, I hope everybody's doing well, and I will see you soon.